As tourists flocked into Ocean City, New Jersey, across the old Route 52 Causeway, the teams charged with building a newer and safer causeway attended the project kickoff meeting. The July 22, 2006 meeting would be the first of many on the $400 million New Jersey Department of Transportation project. The long overdue project would replace the existing causeway and bridges, as well as include local roadway improvements between the Garden State Parkway and Ocean City. Also included is the removal of the Summers Point Circle and replacing it with a signalized intersection. No small task by any means, it was made that much more complicated by the fact that Route 52 is a critical emergency evacuation route for the island town of Ocean City. Crews will not only have to battle tremendous traffic issues, but also deal with the harsh Northeast Atlantic environment. The engineering firm of Michael Baker is the prime consultant among several other consultants that form the Baker team that is responsible for the overall design. As for construction, the first contract of the project was awarded to George Harms Construction Company. It is their expertise in delivering a project of this magnitude that will be crucial to its timely success. The Honorable Governor Causeway was on hand to break ground and get the construction underway.
This is a great day for this community. It's a great day for the state of New Jersey. This is going to be the largest bridge project we have done in this region in the history of the Department of Transportation.
$400 million over probably the next, 6 years. 2 phases on this project. The first 216 or 17 million. The balance coming afterwards on bridge construction is really vital, I think, to everyone here knows, to the families, the communities, and the economy of the region.
Within days, the equipment and manpower needed starts to roll in. Massive barges allow much of the work to be done from the shallow waters of the bay. The existing bridges will need to be monitored to make sure that the effect of construction does not weaken the significantly deteriorated structures. The bridge monitoring is comprised of a series of ultra-sensitive girder and pier-mounted electronic sensing devices that are strategically placed on the existing bridge. These devices will immediately send alerts remotely to Baker engineers, alerting them to the presence of overweight vehicles using the bridge, as well as of any conditions where the existing piers deflect out of plane more than what is permissible. Hundreds of piles will be jetted and driven deep into the floor of the bay, some to depths of 90 feet, to support the bridge structure of the new causeway. Jetting often makes pile penetration easier in sandy soils. Jetting is the process of forcing a stream of pressurized water at the center of the pile tip, thus loosening the surrounding soil, so that the pile drops through the loosened soils into the underlying material. Massive forms are used to support the concrete piles and keep them properly aligned. Each of the piles are carefully planned and inspected by the on-site engineering staff to make sure it will do its job for decades to come. This included a static load test. The static load test was loaded to between 2,100 to 2,800 kips and checked over time to verify that their capacity is what was anticipated. As the project progresses, George Harms' crews know how to make sure the project gets completed on schedule. With multiple cranes that allow for work to commence in multiple locations, coordinating the massive project and getting materials to the site is always a challenge. The new roadway will be raised above the 100-year flood elevation to minimize the effects of flooding. Much of the foundation areas for the road require the ground to be stabilized prior to actually building the roadway. Where high-fill embankments are specified on the islands, vibrocore concrete columns supporting a stabilization mat, or VCCs, were used to stabilize and strengthen the underlying soils prior to the high embankment placement. A VCC is a column of concrete that is pressure injected 65 feet into the soil. The VCCs are placed in a grid pattern between 8 to 10 feet on center. The bridge pier and abutment foundations are required to be constructed in the dry. Constructing cofferdams permits the bridge piers to be built in a relatively dry area surrounded by the waters of the bay. The cofferdams used on this project consist of a series of steel sheeting driven into the mud line to form a rectangular enclosure slightly larger than the size of the footing that is to be built. The piles are then installed within that sheeting enclosure. After the pile installation is complete, a trimmy concrete is poured directly in the water within the rectangular box around the individual piles. The trimmy concrete will harden under the water within the cofferdam enclosure. Afterwards, the water above the trimmy concrete is pumped out of the rectangular sheeting box, thus creating a dry condition for the construction of the concrete footing. The footings are formed within the cofferdam. Thousands of pounds of steel reinforcement are placed within the footing formwork prior to pouring the concrete. Cooling pipes are also placed within the footings to control the temperature increase that occurs when mass concrete pours are made. The footing forms are removed after the concrete has cured. The construction crews constructed all of the concrete piers on site. To do this, they created reusable formwork that allowed the columns and caps to be constructed consistently. The 138-foot pre-stressed concrete girders that form the Causeway Bridge superstructure are constructed off-site in a carefully controlled facility in Cape Charles, Virginia. The massive Bayshore concrete plant will produce 243 beams by the end of the first phase of the project. Getting them to the project is another project by itself. Building a bridge on the Intercoastal Waterway does have some advantages. Up to 7 beams at a time are loaded onto barges and shipped up the coast to the project. The captains and crews did an excellent job of supplying the crucial pieces to the bridge, where cranes could then pick the pieces and put them precisely in place. Even though the girders are 138 feet in length, the tolerances for proper placement were less than inches. Of course, the skill of the crane operators and the setting crews is what built the bridge one span at a time. With beams in place, crews can start to construct the concrete roadway. Precast deck panels are first placed between the top flanges of the girders, immediately adjacent to each other along the entire span length. These panels serve as the formwork that will accommodate the concrete deck pour. In addition to playing this role, these panels are themselves reinforced and serve to act compositely with the concrete deck pour, thus becoming a structural part of the roadway. The green bars you see are specially treated steel reinforcing bars, or rebar. They are connected by hand to create a mesh. This mesh keeps the concrete together for decades and is precisely engineered. The use of deck panels significantly reduces the amount of rebar needed within the deck slab. Truck after truck brings the high-strength concrete to the project once the deck begins to be poured. The engineers test each batch of concrete to ensure a reliable bridge. Barriers are built in place using another special piece of equipment, a slip form. This allows the concrete to be poured as the machine moves along. The slip form enables long lengths of barrier to be constructed in a relatively short time. To make the bridge safer for traffic, special machines put grooves in the surface of the roadway. This will aid in providing better tire traction. As the North Causeway Bridge became a reality, the advantages of a dual roadway became evident. On a cold night in December, the traffic that was traveling on the existing Route 52 could now be diverted to the new causeway. A temporary connecting road was quickly built for the transition, and traffic was on the way, flowing smoothly onto the new bridges and roadways. The existing bridge over Rainbow Channel was now permanently out of service and ready for demolition. This marked a huge milestone in the project. Now work could begin on the southern half of the causeway. Piece after piece is cut apart, pulled out, and hauled away right down to the piles. This demolition would take several months, but before long, the crews began building the new southbound roadway. With traffic operating comfortably on the northbound roadway and work well underway on the southbound, the second phase of the overall project can begin. The engineering for the new bridges that will extend the causeway by connecting to the mainland on the Summers Point side and to Ocean City on the island side is completed by the Baker team. With that done, construction is set to commence by mid-2009. The Route 52 Causeway is a massive project, one of the largest in this part of the state. But through the combined efforts of the New Jersey Department of Transportation, the teams of engineers and inspectors, and the hard work of the men and women in the field, the project will be a huge success and deliver a great roadway to service the communities for generations.